Now we want to look at the trig identity for sum and difference of angles. We'll talk about sum and difference of angles. You have two angles, they are added or they are being subtracted. One of the most important trig identity under consideration here is that of cos alpha minus beta. So we are taking the angles to be alpha and what? Beta. On the condition that alpha is greater than beta. Once we derive the cos alpha minus beta, we're going to use it to obtain sin alpha plus beta, and then based on these two trig identities, we will expand and obtain many other trig identities. So it's very important that we understand this derivation, as every other identity we are going to meet is dependent on them. Follow me along as we consider our unit circle once again. And this time around, we are going to pick 2 points found on the circumference of a circle with angles from the positive x-axis. Please watch the board. Now we have these points P and point Q. Point P made an angle beta from the positive x-axis. I used blue marker to represent it. Point Q made an angle alpha from positive x-axis. I've used black marker to represent it. Now, what is going to be the angular difference between these 2 points? It's going to be alpha minus beta. Why did I say that? How true is it? Please just take a look at the board. Let's see what happens. Suppose I have a total angle, call it alpha, from this point to this point. Then I have another smaller angle from this point to this point. Let's call it beta. Now, if from this point to this point is alpha, and from here along it to this point is beta, what is going to be the remaining value of this angle? You know it's going to be the total minus the smaller part within it. Is that not so? So that is how we call the value of the angle between P and Q to be alpha minus beta. I used red marker to show it. Now, what if you are asked to hold these 2 points P and Q and then rotate? You know, the distance will remain the same. POQ is a sector. Just think about an orange fruit, such that you cut the orange into the middle from one angle, cut again from another angle into the middle, and pull off what you cut. That part you cut off is called a sector. Now let us assume that you hold these 2 points now along this sector and then you rotate it such that point P now lies on the horizontal axis. If point P lies on the horizontal axis, point Q will move into the first quadrant. That will give us this shape. And we call their new position P prime and Q prime, where P prime is lying on the horizontal axis now. These 2 shapes are similar. We call it congruent shape. The reason why is that the arc length PQ will be equal to the arc length P prime Q prime, because you did not push the 2 points together. The 2 points remain at the same point they were. You only rotated the sector. At this point, we want to locate points P and Q and point P prime Q prime using their coordinates, just like what we saw in our previous video when we introduced the concept of unit circle, converting the x and y coordinates into their polar form, cos and sine of their angles respectively. Are we ready for that? So let's see. This point P, you know, we can locate it as x1, y1, and then point Q as x2, y2. This x1, y1, x2, y2 can be converted from Cartesian coordinate to polar coordinate, considering the fact that this thing The 2 points are on a circle, a curve. So if we are converting the x1, y1 coordinate of P now to cos and sine of the angle, the coordinate of this P is going to be cos beta, comma, sine beta. Because the angle that P made with x axis is what? Beta. What about Q? The coordinate of point Q, knowing that the angle it made with the x axis is alpha, its coordinate is going to be cos alpha, comma, sine alpha. Cos alpha for x2 and sine alpha for y2. So you see that? So we are saying that this is, okay, let me use our red marker. This is x1, y1, x2, y2 for this circle. Now what is going to be the coordinate of P prime, Q prime? There's something I want us to observe here. Take that this time around P is lying horizontally. So it's just like maybe you have a graph like this. Now Q prime is in this quadrant. So it made an angle. It made an angle alpha minus beta. And then this is P prime. This is the origin 0, is that not so? You know that P prime is lying on the horizontal now. And this horizontal from here to here is the radius of the circle. This is a unit circle, so the radius is equal to 1 along the x-axis, which means that this is going to be 1 unit. 1 unit along the x-axis. So if you're locating P prime now as x1, y1, for example, I follow. The x1 value here is going to be 1, and the y1 value here is going to be 0. 1 because the length along the horizontal axis is 1 unit, fixed to the origin on y-axis, which is 0. Does that make sense? Then let us locate Q prime. Take note that this time around Q prime has an angle alpha minus beta measured from the positive x-axis. So if you want to locate the x and y coordinate of Q prime, it has to be converted to its what? Polar coordinate respecting these angles. So the x2, y2 coordinate of Q prime will now become, look at the angle, alpha minus beta. It's going to be cos alpha minus beta, comma, sine alpha minus beta for the x and y coordinate of Q prime respectively. You can see that. Okay, now having explained this, remember that we stated that this shape and this shape, they are congruent, they're similar. The arc length here, PQ, and the arc length here, P prime, Q prime, they are equal. They are equal. Look at it. Arc length PQ equal to arc length P prime, Q prime. Now in the next video, we are going to consider the distance between 2 points using the knowledge of coordinate geometry. Distance between 2 points formula, on the condition that the arc length in the 2 circles are equal. So we're going to get the distance between the 2 points of this arc length and the 2 points of this arc length. Once we get them, we will now equate them knowing that they are equal. From there, we will prove cos alpha minus beta. But then we're going to go for a short break. When we are back, we'll do that. You are welcome from the short break. I want to believe that during the break you took your time to look through the explanations given about points P and Q in figure 1 and points P prime, Q prime in figure 2 as regards the arc length. Most importantly, what we said regarding the coordinates of this point. That's very important. With that, we are going to apply the distance between 2 points formula to determine the arc length in figure 1 and the arc length in figure 2. That is PQ and P prime Q prime respectively. But what is actually the distance between 2 points formula in coordinate geometry? We have the formula on the board. Just imagine you are talking about 2 points, alright, of a line. One of them is P, the other is what? Q. And P has the coordinate x1, y1. Q has the coordinate x2, y2. If you want to get the distance between the 2 points, the formula is given as PQ prime, that's PQ raised to power 2 rather, equal to x2 minus x1 all raised to power 2 plus y2 minus y1 all raised to power 2. So we're going to apply this formula to each of the arc lengths PQ and P prime, Q prime of figure 1 and figure 2. What is that going to give to us? Already we've established their coordinate previously before the break. So going to figure 1, we are going to get this. The arc length PQ of our figure 1 would have the distance between it as this. PQ raised to power 2, that's the arc length now squared, will be equal to cos alpha minus cos beta all squared. Remember, this cos alpha is our x2 coordinate. That is the coordinate of point Q of that figure 1. So this is like x2 and this is x1. Then plus y2 minus y1. Our y2, when we consider that figure 1, arc PQ, our y2 there was sine alpha, which is the coordinate of P in the y-axis. So this will become y2 and then y1 sine beta, which is the y-coordinate of point Q in that figure 1. So we're going to put this in bracket and then square. So you see how we apply this formula, distance between 2 point formula to our arc length PQ. So all that is left is to expand this term. And how to expand this? It's simple. It's just like somebody giving you x minus y all squared. Now how to expand that, is that not so? It's going to be x squared minus 2 times x times y, then plus y squared. You can do that yourself by writing it x minus y all squared is equal to x minus y times x minus y. If you expand this, you're going to get x squared minus 2xy plus y squared. So that's what we did here. If you expand this term, you're going to get this term. I've written the first expansion, that is the x2 minus x1 in blue marker, and then the second expansion, y2 minus y1 in black marker, so I can differentiate that. And having expanded these two terms, this is what we have: cos square alpha minus 2 times cos alpha times cos beta, then plus cos squared beta. Do same here. You're going to get sine square alpha minus 2 times sine alpha sine beta, then plus sine squared beta. Then, having done this expansion, take note, we can pick this cos square alpha plus sine square alpha, because both of them is bearing alpha alpha at the same angle. And you know that sine square theta plus cos square theta will give you what? 1. That's correct. Therefore, if I pick cos square theta plus sine square theta, I can also pick cos squared beta plus sine squared beta, because they have the same angle. See that here. Then we move on, minus 2 cos alpha cos beta minus 2 sine alpha sine beta, which is what we have here. This term will give us 1. This term will also give us 1. Look at the 1 plus 1 minus this term and this term. You can see that here. 1 plus 1 will give us 2. So the arc length PQ squared, the distance between those 2 points, is going to give us this along that arc in figure 1. So we're going to call this equation I. Let's keep it as area. I've gotten the arc length there. We would apply the same principle, the same formula, distance between 2 points, to arc length P prime Q prime of figure 2. And you know their coordinates already. So if you substitute, P prime Q prime squared is going to be cos alpha minus beta minus 1 all squared. You remember that cos alpha minus beta is the x2 coordinate of point Q. And then this 1 is the x1 coordinate of point P. So I can fix this is x2 of point what? Q. And this is x1 of point P. Is that okay? Then plus, similarly, you repeat the same thing for y2 minus y1. For point Q, the y2 coordinate is sine alpha minus beta. And then for point P, the y1 coordinate we obtained was 0. So this is y2 for point Q, that's Q prime, prime, prime. And then this is our y1 for point P prime. So that is just the point there. So what do we do all in all? Simplify. Expand the bracket like we expanded here. I've given you the link to how you do this expansion, so you can work around that. If you do so, you are going to get 1 plus 1, because at this point you're going to get cos square alpha minus beta plus sine square alpha minus beta. Since both angles are equal, that is sine square alpha plus cos square alpha minus beta, so it's going to be equal to 1. When you do that, you will get 1 plus 1, which is 2, minus 2 cos alpha minus beta. I call this equation II. This is the arc length value P prime Q prime. And remember we said that the arc length PQ and the arc length P prime Q prime are equal, is that not so? So we're now going to equate both of them and then solve to obtain our cos alpha minus cos beta. Once again, we'll go for a short break. Take your time to walk through what's written in the board here and the explanation given so far. When we are back, we'll round off with what we want to derive, cos alpha minus beta. You are welcome from our short break. We are now ready to complete our ride on the derivation of cos alpha minus beta. Recall, in the previous video before the break, we were able to establish the arc length values, that is P, Q squared and then P prime, Q prime squared. These two are the arc length values for our figure 1 and figure 2 of our previous unit circles. Having obtained these arc length values, and we know that the two figures, figure 1 and figure 2, are congruent shapes. We stated before now that we have to equate the two arc lengths. We need to make them equal. And of course, that is what we have on the board here. Okay? So we need to recall from the unit circle analysis that arc length PQ is equal to arc length P prime Q prime. Therefore, if we equate the value of the arc length we got, this one, 2 minus 2 cos alpha minus beta, is the value of arc length P prime Q prime. It's equal to the value of arc length PQ, which we got to be 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. So what do we do from here? You will notice that by collecting like terms, these 2 and 2 are like terms, equality is there. So if you move these 2 to the other side, it becomes 2 minus these 2, which means that these 2, they are going to cancel out. Is that okay? They are going to cancel out. And if they cancel out, we have minus 2 cos alpha minus beta, which is this term, equal to minus 2 cos alpha cos beta, and then minus 2 sine alpha sine beta. What do you notice is common to all these terms, the 3 terms we have on the board here at this point? Minus 2 is common to the 3 terms. So we can divide through by minus 2. And if we divide through by minus 2, this minus 2 would become positive 1. 1 times cos alpha minus beta will give us cos alpha minus beta, which we are deriving. Is that answer? Divide this by minus 2, you will get positive 1. 1 times cos alpha cos beta will give us cos alpha cos beta. Divide minus 2 by minus 2, you will get plus 1. Plus 1 times sine alpha sine beta will give us plus sine alpha sine beta. Have you seen something, right? So the value of cos alpha minus beta, that trig identity is equal to, that is cos alpha minus beta is equal to cos alpha times cos beta plus sin alpha times sin beta. And we are done proving the trigonometric identity for the difference between these two angles, alpha minus beta, in terms of cos. Now, let me ask the question, what if you are asked to obtain the value of cos A minus B? How do you write that? All you need is this identity here, is that okay? So it's going to be cos A times cos B plus sin A times sin B. So that's going to be equal to cos A cos B, and then plus sin A sin B. That is how it goes. In the next video, we're going to work on obtaining the value of the trig identity cos alpha plus beta sin alpha plus beta sin alpha minus beta, based on this fundamental concept of difference between two angles that we've established.